Someone be brave. Volunteer. Oh, also, I had a conversation with my wife last night that she asked me to pass something on to you guys, and so now I will. I told her what I said to you guys yesterday about caring less about whether you're right or wrong and just wanting you to like commit. And I told her I asked the question whether you're right or wrong. Sometimes I will ask you if you're sure, in an effort to try and get you to commit. And she said, "Oh, that's interesting." She said, "I would still be terrified." My wife was not a good math student growing up, and still has like hard anxiety from math. And she's married to a math teacher, so that's interesting. But beside the point. One of the things that she said, give them the option to say, when I ask you if you're sure, give you the option to say, nope, but I'm going to go for it. Just to be like, no, I'm not totally sure, but I'm committing to my answer, regardless of whether it's right or wrong. I don't know, but I'm gonna commit. And she said, I don't know if they've thought about this, but if my math teacher told me that, he asked if I was unsure, and I was free to say, no, I'm not sure. I really am not sure, but I'm going to go for it. That is an option she said she would take. She asked me to pass that on to you. So that is from my wife to you, the not great math student with intense anxiety, to wherever you're currently sitting at as far as your math career is concerned. If you are like her and deeply anxious about math, maybe that resonates with you. So, anyone willing to jump out there and give me what you think the correct answer to this question is? Nika, let's do it.
I got -2.
Yeah.
And then -0.1 repeating.
Okay.
2/5.
Okay. It was positive in the question.
0.56. -3/4.
Careful, it's not -3/4. It's -3/-4.
Oh, sorry. -3/-4. 1.34. 3 and 2/7.
Did anyone get the same order Nika got? Okay, if we're doing it by democracy, there's some pretty strong votes behind you, Nika. Nika, this is correct. Well done. If you got this, you are set. Does anyone have questions about this? Nika, you have questions about your own correct answer? Okay.
So, if say it was -3/4, it would be negative, but if it's -3/-4 is positive?
Correct. That's why it is located where it is. Yeah. Because it's the double negative. Negative divided by negative is positive. If it was -3/4, it would actually land. It would be the second one that you had listed here. But because you put it in the right spot, that's where I felt free to just draw your attention to that second negative. Any other questions about Nika's ordering? If you were unsure how she did what she did, now is the time to ask. I don't see any hands. So we're going to suggest either you didn't do it and then you think you could, or you did it all right. Which is interesting because like only a third of you put your hand up when I asked you to support Nika's answer. So, well, okay, this is correct. If you got something different and you want my help, let me know. Otherwise, moving on. The next thing I gave you was this page right here, comparing and ordering rational numbers. And question 1 said to express the following decimals as common fractions in lowest terms. Now, this one is kind of a beast because you're taking 9 numbers and you're converting them all to have the same common denominator. Express the following decimals as common fractions in lowest terms. So how do we do this one? Yeah. Okay, so tell me what you did. So like for A, what was your answer for A then? 8 1/2. Your answer for B would have been? Sorry? 53, right, actually -53 and 4/5. So what was your answer for C? Negative 1 over 8. Okay, D. 1 over 200. E. 175 and 1 over 4. Cool. F. Negative 7 over 8. Cool. G. 1 and 3 over 5. H. 55 and 1 over 2. And then I. 7 over 40. Is that what you got? I just want to make sure I heard you properly. Okay, yeah. How'd you get 7 over 40? What'd you do? Nice. And then you simplified it from there. You reduced it way down. Nice. Love it. Okay, so that is the beginnings of this question. But we are not done yet. So the last thing said to write as common fractions. It's hard to do common fractions and lowest terms. So I'm sorry, I miswrote this one. If I ask for it in lowest terms, these are all great. If I ask for it as common fractions, yes, Presley?
I got 7 over 400. Yeah.
7 over, let's check it then. 175 over 10,000. If I divide both of those by 5, 175 divided by 5 is going to be 35. Yeah, thank you. And then 10,000 divided by 5 is going to be 2,000. And then dividing both of those by 5 is going to give me 7, and it is going to be 400. 7 over 400. So, yeah, the wording here I do apologize for. I did screw that up. That was my bad. So if I ask for it in lowest terms, these are great. If I ask for them as writing all of these decimals as common fractions, what you would then have to do is you would have to take all of these fractions and make them out of the same common denominator. In this case, the common denominator of 2, 200, 5, 4, 8, and 400 is the smallest number that all 4 or all 5 or 6 of those numbers go into is what? You've got 2, 200, 5, 4, 8, and 400. What's the smallest number all of those numbers go into? Yes, 400. So what you then have to do is take each one of these fractions and put it over 400. So to do that, I would multiply top and bottom here by 200. So it would become 8 and 200 over 400. This one would become, I multiply that one by top and bottom by 2. Here I'd multiply top and bottom by 80. Because 8 times 5 is 40, so 80 times 5 would be 400. Here I'd my top and bottom by 80. Here I'd multiply top and bottom by 100. Here I'd multiply top and bottom by 200. Here I'd multiply top and bottom by 50. 50, and I wouldn't multiply top and bottom at all. And that would give me a whole bunch of mixed numbers, all with the fractional piece out of 400. Cool? Comments, questions, concerns? I will make sure the wording is clearer should I ask you something like that in the future. That's my bad, not yours. Did anyone understand it the way I intended, or did you all do it the way Carmen did? Yeah. That was not a yes-no question. That was an either-or question. If you say yes to an either-or question, it means both are true. So you did it both ways? Akam? Did you do it both ways? Carmen's way and what I intended? No. Oh. So you're saying yes to Carmen's way? Okay. Just so we're clear. Let's keep going then. Write the following numbers in decimal form. Number 2, any questions about these? These are the values. I'll just jump over here. These are the values that you were looking for. Questions, comments, concerns about any of these? And so far, we're still doing this without a calculator. How did you do C, D, E, and F without a calculator? Long division, love it. Does anyone want to see any of those? Yeah, which ones? Pick one, Akam. C, let's do C. Long division. Here we go. So, oh yeah, Presley?
Were you supposed to round D and F? Because I kept going, so I had it really wrong.
They are. They should end. Oh, they do repeat. Oh boy, do they repeat. Those are gross. How far did you take it?
For D, I got 0.0350877719, and then I stopped because I didn't want to.
If you would have kept going, you would have gotten 298245614, and then it would have looped around to 035087771. Like it would have. Eventually, you would have got to the repeat, which we know has to happen because either it has to repeat or it has to end because 2 over 57 is rational. So that decimal has to end eventually. Yeah, no, I rounded D and F for the sake of long division and sanity. But you could do it. It would be doable. 325 over 7. Where does that end? Oh, that one ends nicely. That one I shouldn't have rounded. It starts repeating after 571 and then 428571. It starts to repeat right there. If you did that one fully. I did chop it off. This one, I'll show you this guy. How do you divide 328 divides into 4? Does 328 go into 4? No. And there's nothing there. So we're going to add a decimal. We're going to add a 0. Does 328 go into 40? No. So we're going to add another 0. Does 328 go into 400? Yeah, you bet it does. How many times? So then 1 times 328 is, cross out the 3, that comes a 10, now it's a 9, that's a 10, that's a 2, that's a 7. Does 328 go into 72? Add a 0, drop it down. How many times does 328 go into 720? It was in twice. This is going to be 656. And this process will continue. Eventually, you're going to hit 195, and then it's going to go 1, 2, 195, and it's going to keep going. If I don't let you have a calculator, and don't worry, I will eventually let you have a calculator. Unless you have another technique for it, long division is what you're going to have to crank out to convert these things. The calculators will come, I assure you. Just not yet. Is that enough, Akam? Yeah. Go with that? Okay. So then we got 3 and 4, negative 3/8, and the opposite. So that's the reciprocal. Reciprocal means you flip the fraction, and then the opposite is where the positive number that you're given is just give me the negative of it. The following numbers on a number line. That was my number line here. I labeled -2, -1, 0, 1, and 2, and I slid them in there. Comparing each we remember these symbols, yes? Greater than, less than? Yes, Danny?
I have a question about number 4. So I have the same answer, but it's like they have the same absolute value.
Correct.
Right? So it's opposite just because it's like mirrored.
Yeah.
Almost.
Yes.
But then what if you ask like, oh, what's the opposite, or like without the absolute value? I don't know how to ask that. Like, if it wasn't they both didn't have the same absolute value, what would be the opposite of 3 and 3/6?
It wouldn't work.
It wouldn't. No. Okay.
A number and its opposite have to have the same absolute value.
Okay. Okay.
That's a good question, though. So number 6, are we cool with greater than, less than? It opens to which number? The larger one. So 3/2 is larger than 4/3. 5/4 is bigger than -7/4. Negative 2.8 is less than 3.1, and 0.01 is larger than -1. And then writing the following numbers in descending order. Descending means biggest to smallest. And then I got ascending, smallest to largest, different set of numbers. A decimal number between each of the following rationals. So you could have had different values here for number 9. I just had 0.7 and -0.6. You'd want to do that by converting 3/5 and 4/5 to a decimal. So that's 0.6, that's 0.8. So the value I picked in between was 0.7, but you could have given me anything between 0.6 and 0.8. 0.61, 0.62, 0.63, 0.64, 0.6444, 0.65, 0.6555, 0.655567. There's infinitely many numbers you could have given me in between there. And then the same thing here, I converted this into decimals as well. This is -0.5, and this is -0.625. So a number between -0.5 and -0.625, I said -0.6. But again, there are infinitely many numbers that you could have picked in between there. And then the fraction between the pairs of rationals. So either you picked a decimal and converted it to a fraction, or you converted these two into decimals, or sorry, these two decimals into fractions. Either way is a totally acceptable way to do it. And then number 11 at the bottom. Give me an example of a fraction in lowest terms that satisfies the following conditions. Greater than 0 and a denominator greater than the numerator. I said a half, but you could have given me anything, 1 over anything. 1/3, 1/4, 1/5, 2/3, 2/4, 2/5, as long as the denominator is bigger than the numerator. Then I wanted a number between 0 and -1 with the denominator less than the numerator. If the numerator is bigger, that means you have a number bigger than, with an absolute value bigger than 1. So such a number where the denominator is less than the numerator and it's between 0 and -1 does not exist. Less than -2 with the numerator less than the denominator. I said something like -2 and 1/2. If you wanted a mixed number. If I wanted strictly a fraction only, the numerator less than the denominator less than -2. Means it's more negative than -2. Can you have a number if it's not mixed, it's just a fraction, with the numerator less than the denominator? That's less than negative. That would also not exist. But if you write it as a mixed number, then there's a loophole for you. Between -1.2 and -1.3 with the numerator greater than the denominator, I did something like this. This was the fraction that I shoved in between there, and I turned that, the mixed number that I put in between there, and I turned that mixed number into a fraction, an improper fraction. And so there we go. Questions, comments, concerns on any of this? Is this kind of sort of making sense? Did I hear a no? Kind of sort of yeah? Kind of sort of no? Come on guys, help me out here. Ty, how do we feel about life right now? Could be better? As it relates to this, or just in general outside? In general? Okay. How do you feel about this? Yes. It's all right? Does that kind of does Ty speak for the class? Okay. It's all right. Could be better. Okay. Are there questions about any of this? Okay. Let's move on. Flip the page. This lesson is really quite short, I think. But there is lots of practice to do. So here we go. Because if I'm not mistaken, lots of this should be reviewy type stuff. So, we're going to look at operations with rational numbers. You've done this before. We're just going to review it. Make sure we're comfortable with it. So we've got, remember sign rules? Basically, I want you to make sure that we're using negatives and positives appropriately. And remembering the sign rules is not a great way to, I mean, it can be a decent way to make sure that you're at least thinking about where things are positive, where things are negative, what it means for different things to be positive or negative. So the sign rules are things like if I multiply two negative numbers, the number I get out is positive. If I multiply two positives together, it's also positive. If it's a negative and a positive multiplied together, negative. Division is same set of rules. But when I add and subtract, do the rules work that nicely? No. Can I add two negative numbers together and get a positive number? I can add two negatives and get a positive? No. Can I subtract two negatives and get a positive? Yeah, but can I also subtract two negatives and still get a negative? Yeah. You understand what I mean? We're cool with that, yeah? Okay. So the sign rules really matter for multiplication and division. You've got to be careful not to abuse those sign rules when you're dealing with addition and subtraction, because they don't work the same way. When subtracting, subtract the smaller number from the larger and take the sign of the larger number. So if I have 4.23 minus 9.21, is that thing going to be positive or negative? It's going to be negative because 9.21 is larger. Absolute value of 9.21 is larger than the absolute value of 4.23. So because this is bigger, it's going to make this thing that much more negative. Multiplying or dividing, you guys have got same sign as positive. When multiplying or dividing two numbers, opposite signs is always going to be negative. But at the end of the day, I think you guys will be fine. So we're going to do a bunch of this stuff, and I don't want you to use a calculator for it yet. I want you. We know how to add or subtract decimals, yes? How do we add decimals? Someone walk me through it. Someone be brave. Tell me what to do. Pretend I'm paying you to tutor me in Math 8. How do I add decimals together? Harwin, how do I add decimals? Okay, so I put the first number like this, 5.97. I line up the decimals. Okay, cool. So 2.701. I'm lining up all of the different places. If there's nothing above, that's a 0 plus 1 is 1, 7 plus 0 is 7, 9 plus 7 is, carry the 1, 5 and 1 is, well, 5 and 1 and 2, I guess, would then be 8. And the decimal goes where? Adding or subtracting, you just drop them in the column. If I had something like this, 8.23 minus 12.41, where the thing I'm subtracting by is bigger than the thing I'm starting from, do we know how to, we're cool handling this? Some yes, some no, okay. So when you're dealing with something like, you're cool with number 1, yes? We're cool? 1, line up the decimals. Same thing with something like this. If the thing I'm starting with is larger, we're good subtracting. And if I have 3.4 minus 1.45, 002. Okay. If I have something that looks like this, 8.23 minus 12.41. Larger minus smaller. So how we're going to write this thing is we're going to rearrange it. It's going to be 12.41. Whoops, that's smaller than it meant to be. Minus 8.23. It does, but it doesn't. The way subtraction works is it actually doesn't. I'll show you why. 12.41 minus 8.23 is, how do I do that subtraction? I can't do 1 minus 3, so what do I have to do? I borrow from the next column over, so that becomes a 3, that's a 1, that's an 8, that's a 1, borrow again, so that's going to become 4.18. But now I go back and I look at this thing. The larger of the two numbers was negative. So then my final answer then also then must now be negative. So my final answer is actually going to be negative 4.18. I rearranged the question, and then I undid that to make it easy to do, and then I undid that rearrangement. Here is how I will prove to you why I'm allowed to do what I just did. Okay? Effectively, what I did to make this happen is I multiplied this question by -1. Okay? So what I did was I said, okay, I don't like that question, so I'm going to multiply it by -1. When I multiply it by -1, this is going to become negative 8.23, and then -1 times negative 12.41 is going to become plus 12.41. But that's weird. I don't want negative 8.23 plus 12.41, so I'm going to rearrange that. Adding a negative and a positive is like subtracting. So this is going to become 12.41 minus 8.23, which is what I did. And then to undo my change, how do I undo multiplying by -1? Divide by -1. Or I can multiply by -1 again, because all that it does is swap the signs. So then I'm going to multiply by -1 again, and I'm going to get my negative 4.18. I didn't do anything mathematically illegal, and it works. Okay? So this is the method behind the madness, or the madness behind the method. Okay, we're cool with that? Kind of, sort of? Yes, Danny?
So, if you actually did 8.23 minus 12.41, like, it's going to be a negative, but what if you had something that was, actually, never mind, it always is. Never mind.
Okay. And the only reason I'm doing this is because I'm requiring you to do things longhand. I'm withholding the calculators for the time being. If this was a calculator, you just crank that in and we'd be good. But I want you guys to be nimble. I'm trying to force you to become more nimble mentally. Ty, Carolyn, we good? Is it working the way it's supposed to be working? Your calculator? Okay. Okay. Yeah, if the technology starts giving you grief and you can't help each other, let me know. Carmen. Say that again. That's effectively what I did. I rearranged them and I added the negative back in. I'm showing you why. Because Harwin made the declaration at the beginning, like, how does that work mathematically? Well, here's why it works mathematically. But effectively, the shortcut is, flip them, subtract them the way we normally do, bigger minus smaller, and then reintroduce that negative. You're not adding a negative, you're bringing it back. It's not like what my classmates and I used to do when I was in university. We'd have like pages and pages of large calculations in my physics class, and we knew what the final answer was supposed to be. And there were times where our final answer, the one that we got, was different from the actual value by a minus sign. And we couldn't figure out for the life of us how that happened. But the equation, like the work we were doing, was literally pages and pages long for the same question. So we would just go backwards. No, bell hasn't gone yet. Don't pack up. This is the 5 minutes for them to come back to class, and then you get to go. So we're not done.
First floor head back to class, second floor wait for the bell.
There it is. So you got 5 more minutes. That's that warning. So what we would do is we would go backwards and we would add a negative sign just totally arbitrarily, deep, deep, deep within our calculation, hoping our professor wouldn't notice that things just all of a sudden changed. And then we'd follow that change all the way through and then our final answer would be correct. And I still to this day don't know what went wrong. And it happened every so often where you get something crazy like that. That is magically adding a minus sign, and that is not okay. But because the calculations were literally pages long, my professors never found it. This actually has a valid mathematical reason for what we did. And there's a difference. One is playing fast and loose and illegal with mathematics. This we actually have a reason for. So something like this, number 5, what would I do with this? Negative 12.5 plus negative 2.4. How would I handle something like this? I'm assuming we're good here, yes? If I've got a double negative, that's just the same as adding. We're cool with that? So I can skip number 4. Jump number 5, Nika. Negative 12.5 minus 2.4? Yeah, you could do it that way. What's the other way you could think about it? Carolyn. Yeah, this expression right here is the same as if I had 12.5 plus 2.4. I added them together first, and then I multiplied them by negative 1. This is the same procedure. So what I can do is then just take my 12.5 and my 2.4 and add them together. 4 and 5 is 9, 2 and 2 is 2, 1 is 1, and make that sucker negative at the end. That should be a 4, yeah. Thank you, Carolyn. And then something like this, if I have negative 0.25 plus 1.6, I'm allowed to add or subtract in whatever order I want, right? I could rearrange these two and get the same answer, yes? 2 plus 3 is the same as 3 plus 2. So I could rearrange these things and say, well, this is just going to be 1.6 minus 0.25, and then we subtract it like we know. We all sort of comfortable with this? Sorry? Okay. Multiplication and division are arguably easier, yes? We multiply the way we multiply, and 2 negatives make it a positive. We divide longhand like we've divided longhand before. How do I divide decimals? Dividing decimals longhand is weird. We don't like it. What do you mean? I don't know what you mean. We'll talk about it after lunch. But there is a technique that we're going to go deal with. Questions like 2 and 4. We're going to come back to those. Presley, do you have a question about one of these ones or about one of these ones? Okay, hold that thought. We'll come back. What is your thought first? You betcha. Yesterday's video was up. Okay. I put it up yesterday after school. Always check. And if it's ever not, you can always email me. Start recording again. So, that means this. Tenmeet, you're friends with Eminette, yes? If you could let her know about the high likelihood of the chapter test on Wednesday, that would be lovely. Do we have anyone here who's friends with Angel? Can you let her know as well? Because I think we're only missing those two. Yes? Tenmeet and Angel are the only desks empty. Fantastic. Okay, here we go. So, multiplying and dividing. Multiplying is easy. We can multiply longhand, yes? Do I need to review one just to make sure we're all good? No. I saw a couple heads go up and down real fast, so let's do it. 2.3 times 8.1. How do I do it? Someone real quick. Hands up. Rattle it through. Danny.
1 times 3.
1 times 3 is 3.
1 times
2.
2. 8 times, next line is a 0.
Ah, yes. So the place value goes in there. So what we're doing here is basically we're doing 1 times 23. And then we're doing 80 times 23, so that first 0 shows up here because now I'm in the 10 spot. So then 8 times 3 is? Thank you. And then 8 times 2 is? 17, 18. So then I'm going to have 3, 6, 1, 8. And what do I do with the decimal place here? Careful. With addition and subtraction, we drop. Harwin. Where do I see how many places I go to find the decimal? So I have one place here and one place here. So how many decimal places do I have total? So then my final answer needs to have 2. Bam, bam. So my final answer is then going to be 18.63. Just a bit of review. Was that a question from the back there? Did I see a hand fly up and then come back down? Yes, Danny.
What if you have, I forgot how to, if you have a decimal place, and if you have a decimal in a different place than in the one, like if it was,
0.81 times 2.3?
sure.
Like if the decimal was here instead of here?
Yeah.
Then I'd have 1, 2, 3 decimal places, then I'd move my decimal place over 1, 2, 3 times.
So that, okay. You just add how many?
Yeah.
1 for each, okay.
Yeah. You move it over once for every decimal space in your answers.
Okay.
Or in the numbers you multiply together into your answer.
Okay.
Does that make sense?
Yeah.
Okay. So that's multiplication involving decimals. Multiplication, addition, subtraction is nice and easy. The place where things get a little bit weird is when we have division longhand via decimals. And this is where things get dumb-ish. There is a technique that at some point you were supposed to be showed. We'll find out. Because I've been talking to some of the other math teachers, and all the math teachers say that all the grade 9s are saying, all we did was patterns. We didn't actually do anything. So I don't know if you did this in grade 8 or not, but there's a technique for dividing decimals. Does anyone know what the technique is? Who didn't learn it themselves somewhere secretly on the internet? You learned this in a class, Presley? Yeah. Which class? It vaguely came back from like middle school?
It was somewhere in middle school.
Fantastic. Then if it's not secret internet knowledge, how do you do it? What's the technique?
Okay, so since it's negative 3.2 that's being divided,
Yeah.
And there's only one decimal place,
Yeah.
you move the decimal over 1 to make it negative 32. We have to do the same thing to the other number, so it becomes negative 32 divided by 16, which is just negative 2.
She's absolutely correct. Let's talk about why that works. So, division is the same thing as writing these numbers as what other object? Starts with an F. A fraction. One of the F words in math that we don't like. Fractions. So this is the same thing as having negative 3.2 over 1.6. Now, we don't like having decimals in fractions. That's just no bueno. So to get rid of decimal places, what do I now have to multiply the numerator and the denominator by to move that decimal over? Multiply the numerator and the denominator by 10. So I'm going to multiply by 10. I'm going to multiply by 10. What that's going to do is it's going to slide this thing over. It's going to become negative 32 over 16. When I multiply the numerator and the denominator by the same value, does it change the question? No, because it's like multiplying by 1. Because basically what I'm multiplying here is by 10 over 10. 10 over 10 is 1. So I'm multiplying by 1. It doesn't change the question. So, well, it doesn't change the meaning of the question, but it means that instead of having negative 3.2 divided by 1.6, you've got 32 divided by 16. This is totally doable. 32 divided by 16 is, and then it's negative because this value is 2. Okay? So that's the technique. When I have a single decimal place, I multiply by 10 to move it once. What if I have 2 decimal places? Carolyn? How'd you do that? What do I have to, what do I have to multiply by to move the decimal? Okay, so you can think of it that way. Whatever I move, I have to move the decimal the same amount both times. Technically speaking, what we're doing to move the decimal is multiplying, in this case, by 100. Every additional power of 10 moves it one more time. So I'm going to move it twice and twice. So this is going to become 5 divided by 10, which if you want to think of it in terms of fractions, sometimes it's easier to do that way. 5 over 10 is a half, which is 0.5. Or you could have done 5 divided by 10 longhand. That's relatively easy to do. 10 goes on the outside, 5 would go on the inside. 10 does not go into 5, so we add the decimal and a 0. 10 goes into 55 times, nice and easy. And then the decimal just jumps up. My answer is then 0.5. Oh, you mean you were at this stage. I wanted to, yes, that is true. But we can't do this until we do this. And so that's the first piece I was looking for. This is absolutely correct. Yes, we line up the decimal place. Harwin, you were completely correct. Questions, comments, concerns about stuff like 2 and 4? Is that ringing any bells of math long gone? Okay. I'm sorry if that's brand new. It's a relatively easy technique though, yes? As many the most number of decimal places you are, that's what you want to get rid of. So we want to get rid of the 2 here. So this is going to move twice, so this one is also going to move the same amount. Because whatever I do to one, I've got to do to the other. Otherwise, it's no longer the same question. So the rest of these, 5 and 6, 3 I think is easy. You can do that longhand because it's just like number 1. 5 and 6 is bedmass, but it's bedmass longhand. So you're going to, this you can do. 0.2 times 31. You can do that longhand. That would be 31 times 0.2. It makes it easier to put the decimal on the bottom if there is one. If there's only one with decimal. 2 times 1 is 2. 2 times 3 is 6. And it's just 0.2. There's one decimal place, so this is going to be then 6.2. So this thing then becomes 6.2 divided by negative 0.31. Yes? Yes, because I dropped the negative. It'd be negative 6. Thank you, Presley. Negative 6.2 divided by negative 0.31. How do I deal now with that? Yeah, multiply both numbers by 100 to move the decimal twice. So then it's going to go boom, boom. So then it's going to go boom, boom. So this is going to become negative 620 divided by negative 31, which is going to be not 2, it's going to be 20. So if you can see that nice and easy, great. If not, we can do it longhand. 31 goes into 62 twice, I think. Makes sense. Am I doing that right? 31, 60, 620. It goes in there twice. 2 times, no, yes, is 62. 0, bring down the 0. 31 doesn't go into 0. Goes in 0 times, and we're done. Yes.
Yeah.
Where are you talking? What did I do?
Like, wouldn't it be like 31.0 and then 0.2? Like, wouldn't you
When you're adding, you have to have, you want to line them up. So we would do it that way. Because we're not adding it, because we're multiplying, we don't actually need to add the 0.0. You just do the 2 times 1 is 2, 2 times 3 is 6. And because in the two things we're multiplying together, there's only one decimal place, then I would just start here on the right-hand side and go in once. But you don't, again, when you're multiplying, you don't need to include it. You only need to worry about that if you're adding or subtracting, where you have to line the decimal places up. In multiplication, you don't need to line the decimal places up. And division, you want to get rid of the decimal places before you do the division. So don't add more than you have to, necessarily. Does that help, Nika, at all? Okay. And then 6 gets done just like 5. I will leave you to do 6. I want you to try this one. I want you to try it right now. The answer you're looking for is negative 13.3. If you haven't done it yet, give her. Right now. Do it. Yeah, I feel like you could get all the way to 11 a.m. for a drink. I really don't want to give you guys a test on Wednesday. I really don't want to, but I don't know when else to do it if not on Wednesday. Yeah, you don't want, well, we're going to start another chapter. No, we start the next chapter. I'm not giving you the entire week for review. That is not happening. No. This is just no. I can't. I don't have time. Oh, I hate the double blocks. Ooh, I will give you guys another option. Okay, how we doing? Did we get negative 13.3? Hands up if you have successfully already got negative 13.3. Okay, if you have not, and you're still if you're still making progress, great. If you're not, if you're stuck, feel free to ask me or one of the persons around you. I'm happy to assist. I have a proposition for you. Here's the proposition. Your test is not Wednesday. That's my proposition. No, it's not on Tuesday. The only other day next week that I can give you a test, and the only way it can possibly be Friday, is because but we have math first. That's your only other option. It's Wednesday, or you come in for a tutorial and do it then. Those are your options. Wednesday, or you, and you know what? Yeah, it's Wednesday, or you come in the Friday morning for a tutorial. Like at the regular time, you'd come in anyway on a Friday, on a tutorial Friday.
Well, it's like a double walk anyway.
That's the only other time. It's Wednesday, or it's you come in for a tutorial on Friday morning. Sorry? You'd get longer on Friday. Okay. So, here we go. I want to give you guys, because it does impact how I give you your homework today. It will impact how much homework I give you over the weekend, and then the time I give you for review and stuff next week. So the only other option is for you guys to do it Friday during SL or during tutorial. Again, you'd be coming at the normal time anyway. It just means you don't get to sleep in the extra hour. It's not that big a deal. No, it's really not that big. For one Friday, it's not the end of the world. So, and I'm going to put it to a silent vote. And I'm going to put it to a silent vote right now. And do I just say majority? We'll see what the numbers are. Okay, so I want everyone to put your heads down on your desk like we're playing 7-Up. The other thing about Friday is you'll get way more time to complete this thing if you write it on Friday than if you write it on Wednesday. You'll have more time. Okay, so hands up for keeping it on Wednesday. Hands up for moving it to Friday and you come in during the SLO. I said heads down. Okay, and wake up. Friday it is. So I'm calling all of you in for SLO or for tutorial on Friday next week. I'm signing you all up for tutorial next Friday. If I have to email, you know what? And I'll just email home to do that. 8:10, yeah. Yeah. Oh yeah, let her know. Those two votes won't mean anything. And I'm recording the video right now, so they're going to see it in the video. Yes, the test is no longer Wednesday. Your test is definitely going to be Friday, which is actually going to reduce how much work I assign to you now. So if you're still working on negative 13.3, I want you to make sure you can do this. The homework then, I believe you should be able to do this. This is all multiplication and division with fractions. We can do this, yes? We kind of have already done this. This I want you to do for homework. Okay? The only snaggly bit is what do you do with something like number 8? If I have 1 over 9 times a whole number, what do I do, Tenmi? I put the whole number over 1, and then I multiply it like I multiply fractions. How do I multiply fractions? Across. I multiply the numerators, I multiply the denominators. So this is going to become negative 6 over 9. And then what's my last step, if I can do it? I reduce. Something we forgot to do on the quiz, most of us. Negative 6 and 9 are both divisible by? So that's going to give me negative 2/3. Cool. I want you to do those. No. I want you to do this page. This whole page is also going to be homework. And the back page. This page is also homework. On Tuesday, Tuesday, what we're going to do then, instead of giving you just the whole review block, we're going to do a bit of a crash course on word problems on Tuesday, because I know how bad some of you guys are. So where it says evens, forget the evens. We're going to spend Tuesday reviewing how to think through word problems, and then you'll have some time to review. Wednesday, I'll likely give you a review as well. Thursday, we'll start exponents. Friday is your test. So you all are coming in for tutorial on Friday morning next week. Is happening. Even if someone says, no, it's not tutorial, it's SLO, you're coming in. Friday morning. It's happening. We have math first. So it goes tutorial straight into math. But that class is only an hour, that math class is only an hour long, and I don't think you're going to finish the test in an hour. That's the only other way to do it, is for you guys to come in during SLO. Sorry? Yes. You'll have the time available to you. From when you show up till SLO till the end of that block. No. Probably, well, unless everyone finishes it early, and then we will. But if not everyone's done, then I'm not going to make you do anything new. Yeah, Danny.
What happens if the week, like if there's no, if it doesn't go back to normal?
If it doesn't go back to normal, then it'll be Thursday.
Okay.
If it doesn't go back to normal, I don't want the test to be Wednesday.
Yeah.
I want to have more buffer days.
Yeah.
So if it doesn't go back to normal, test will be Thursday. Okay. If it does go back to normal, you're coming Friday morning. Okay, that is your work. Get to it. You have a little bit of time left now before the bell goes. There's a fair bit there. I want you to practice it. I want you to do so much because I want you guys to get faster at this. Now I think is a good time to address this, ladies and gentlemen. Carmen, one sec. The one thing, I don't know if you're aware of all of the fun apps that will likely solve all of these problems for you. Don't use them. They will not ultimately help you. Lots of students are like, oh yes, but I use Photomath and Symbolab it shows me the steps. It shows you the steps, but you don't actually do the steps, and so you still, even if you see the steps, you don't know how to do the steps yourself. If you're using Symbolab or Photomath, the only thing you should be using them for is to check a final answer after you have attempted the question. And I assure you, I know when it's being used because Symbolab and Photomath will tell you to do things in ways I have not taught you that unless you've spent the entire summer doing math for fun online, you won't know how to do. And it's exposed students in the past. Like when we went online 2 years ago, I know most of my students were using Photomath and Symbolab because they were doing things that were way beyond what they should have known how to do, and they were all doing it the exact same way. Okay? If you're using those things, the only time you should be using them is after you're done what you're going to do. Carolyn, was that a hand? I thought you had your hand up. No hand? Okay, cool. Yeah, work to the bell. When the bell goes, you may also go. Have a great long weekend. Tuesday, we review word problems. Okay.
So I have a question.
Yes, Dan.